Tabletop Science. I'm Lynn Brunel. It's that time of year again. The days are getting shorter, the nights are getting longer, the air's getting crisp and cool, the birds are flying south. It's fall. And the leaves are changing colors. Well, today we're going to talk about leaves that change color, and we're going to do a really cool experiment to show you that the color's in the leaf the whole time.
Okay.
If you're lucky enough to live in a place where the leaves change color, you've probably seen some go from green to orange.
Orange.
Probably seen some go from green to yellow.
Yellow.
And you might have even seen some go from green to red.
Red.
What?
See, in the summer, the leaves are green for a reason. They're out there doing their job. They're little food factories. In fact, they're the only things on the planet that actually make their own food.
Really?
The green comes from a pigment called chlorophyll.
Chlorophyll. Chlorophyll.
And when that is hit with sunlight and air and water, it does a thing called photosynthesis.
Photosynthesis.
It makes sugars from sunlight.
Photosynthesis.
Huh?
It means, putting together with light.
Cool.
But why do leaves change colors? Why do some turn red? Why do some turn yellow? And why do some just turn brown and fall off the tree? What's going on? There are three different pigments in leaves that give them their color. The chlorophyll is what gives plants the color green.
Chlorophyll.
The red color comes from a pigment called anthocyanin.
Anthocyanins.
Carotenoid creates bright yellows and oranges.
Carotenoid!
In the fall, the sun doesn't shine as much. There's less sunshine, and so the leaves start to break down. And what breaks down first is the chlorophyll.
Chlorophyll.
The green color. When the chlorophyll breaks down, the green goes away. Goodbye chlorophyll. Goodbye green. Goodbye chlorophyll. When it disappears, you can see some of these other pigments that have been lurking underneath the surface starting to show up.
Huh. Cool.
So if other colors like yellow and red are inside each of these leaves, how come we can't see them? Well, we can, kind of. Try this. What you need are some fresh green leaves. You need a jar. You need rubbing alcohol, a pencil, a penny, a pair of scissors, some tape, and a coffee filter. Then you're going to take your coffee filter, you're going to cut. I like to use a strip that's about 1 inch wide and about 3 inches long. And you're going to cut the end into a point.
Okay.
Then what you're going to do, about half an inch down from the point, you're going to take your penny and your leaf and you're going to make a mark. You're going to grind that chlorophyll into the coffee filter. Because you want a good, solid green smudge. Green smudge. Then what you're going to do is you want to hang it in your jar, but you don't want the tip hitting the bottom of your jar. You want to leave about that much space to the bottom of the jar.
Okay.
Ta-da! Then you're going to take your rubbing alcohol. You might need a grown-up to help you with this. And you're going to fill it to the point where the tip is just touching the alcohol, but no more. There we go. And then you're going to set it aside for an hour or so. Ta-da! See? That red pigment was hiding in the green leaf the whole time. It's called chromatography.
Chromatography. What? It means color writing.
Scientists use it all the time. It's a way to get kind of a color fingerprint of a chemical. And when the rubbing alcohol, which is a solvent, hit the paper and went through the green smear of leaf smush, it separated the molecules. It separated the chemicals. The red chemical has a smaller molecule, and the green has a bigger molecule. So the heavier molecules stay down there, and the lighter molecules are carried further up the paper. Try it at home. Gather some leaves, smush them on some coffee filter paper, dip them in alcohol, and make yourself a chromatogram.
Chromatogram.
And if you don't have leaves, don't worry. Use ink. Try it. It's fun.
Try it.
See you next time. I'm Lynn Brunel for Tabletop Science.